Taylor's demise. Gabe, Brian, and Zach are all standing on top of a roof trying to hit Taylor with water balloons. Gabe is standing directly above the door, Zach is 2 feet behind him, and Brian is 2 feet behind Zach. The roof is flat and 10 feet above Taylor's head. If Taylor walks out the door directly below Gabe and walks away at 2 miles per hour, and Gabe throws his balloon at an angle of 45 degrees and at a velocity of 8 feet per second, then how long should Gabe wait to throw the water balloon after Taylor exits the door in order to hit him?
If Brian throws his balloon at a 50-degree angle and at a velocity of 14 feet per second, then when should he throw it in order to hit Taylor? Reference handout for previously stated details. Take this time to evaluate the questions on the handout given to you.
The first thing we must do to solve this problem is figure out the equations for Taylor and for both of the water balloons. To find the equations of the water balloons, we must keep in mind that y equals negative 1/2 g times t squared plus the quantity v times the sine of theta all times t plus the initial y value, and the x value would be velocity times the cosine of theta all times t plus the initial x value. These two equations would give us the separate equations of the water balloons.
To find Taylor's equation, we must consider that his y is staying constant and his x value is increasing at a constant rate. Therefore, y equals 0 and x equals velocity times t.
Now we must plug in the values. In order to find when Gabe should throw his balloon, we must first figure out how far away it will hit Taylor and how long it will take to get there. So once we plug in Gabe's values of velocity and angle for the y and x equations, we get this.
Then set the y equation to 0 and evaluate to get the time. Then plug in the time for the x equation and evaluate to find the distance the balloon traveled.
Now we must also find how long it takes Taylor to get to where the water balloon will hit, so we must plug in the x value to Taylor's equation and evaluate. Then find the difference in the amount of time it takes for Taylor and the water balloon to reach the point of impact to find how long Gabe should wait to throw his balloon.
Now, in order to find how long Brian should wait, we must evaluate the same way but take into consideration that Brian is standing 4 feet behind Gabe. This means our initial x value needs to be negative 4.